All right, guys, so we're going to find the limit of a trigonometric function. So here we're going to find the limit of sine of 2x, tangent of 4x, all over 4x, sine of 4x, as x approaches 0. So here there are two ways in solving this problem, which is one, the common way is, what do you call this one? Is by tabular form, approximation. Basically, it's like this. First, you have to compare its left side and right side, or right hand side rather. And in each side, you have a two column x and f of x. All right. So you could say that we're going to substitute something here. But the question is, what would that be? So here, in the left side, we are actually going to substitute x values that are approaching 0 to the left. All right. So we think that 0 is like the middle here. And then we're going to substitute x values closer to 0. So like, for example, negative 0.1. Substitute negative 0.1. What would be the answer here? Now, next, make it even closer to 0, like 0.01. And then negative 0.001. And get the results, at least, may just say 4 or yeah, 4 at least. Then we're going to take a look starting from here, going to n at what number it approaches. And that's the same thing goes on to the right side. So 0 to the right, so maybe we can use 0.1, then not negative, it's positive. 0.01, then 0.001, and do the same thing. Find each f of x where your x is 0.1, 0.01, so on and so forth, and take a look from start to finish at what values they are approaching, and then make sure that whatever values they are approaching, make sure they are the same. So for example, if the answer here is 1/2, they are approaching to 1/2, then on the right side should be also 1/2. If they are not the same, then the limit does not exist. So that is how you're going to do if you're going to talk about approximations, like substituting x values. But in here, what we're going to do is we're just going to do uh, algebraic and trigonometric manipulation. All right? But before we do that, the first thing that we must do is we will substitute our input 0 in this function. So let's try to substitute it first. All right? So we have sine of 2 times 0, tangent of 4 times 0, all over 4 times 0, then times sine of 4 times 0. So sine of 2 times 0, that's basically 0, and sine of 0 radians is basically 0. Tangent of 4 times 0, which is still tangent 0, which is still 0. All over 4 times 0, 0, and sine 4 times 0, it's still 0, so we will have 0. So it's actually undefined, and to be particular, this is actually we call as the indeterminate form. So what are we going to do now? So now that uh, we're done substituting it directly, now we're going to manipulate this given function algebraically and trigonometrically, right? So let's begin. You see, we have sine of 2x here, right? And then suddenly we have like 4x here. I can actually separate sine of 2x all over 4x and tangent 4x all over sine of 4x. Basically, I can separate them into two fractions. We can do that. So the limit of, let me just put a parenthesis, sine of 2x all over 4x times, wait, 4x times tangent of 4x all over sine of 4x as x approaches 0. All right. So why did I separate them? Why did I have two fractions? So here's the thing. There's actually a limit for a sine function for this. Like it's actually very similar. So we have the limit of sine x all over x. as x approaches 0. So if we have a limit of sine x all over x as x approaches 0, the answer here would be actually 1. Right? So the goal here is simple. Make sure that the x on, or yeah, the x, wait, no. Yeah, the x on the sign and the x on the denominator are the same, right? And of course, the input should be 0. So, for example, the limit of sine of, let's just say, 4x, right? All over 4x as x approaches 0. So you see, the 4x on the sign is just the same as 4x on the denominator, right? The same x's. And then the input is 0. So here, the answer here is 1. I think what I'm trying to say is that the coefficient of x, much better. The coefficient of x in the sign and the x below should be the same. All right, so if we have 4, 4, and then the input is 0, then automatically is 1. Now let's go back here. Can we make it like this though? We can actually, we can. So you see this 4, you see this? I can make it into 2 times 2 instead of 4, right? Overall, 4 is just the same as 2 times 2. So sine, wait, let me write this one properly. So we have sine of 2x all over 2 times 2x. You see that? So now let's take a look here. Let me just copy the other functions. So you see, we have 2 times 2x. Now, what we can do here is I can simply bring out the 2 outside. I can just simply bring it out. All right? What I want is to have sine of 2x and all over 2x only. Because again, just like what I tell you earlier, that if you have a sign on above and then the constant of x here, it's just the same as the constant of x here as well. Like if we have 4x above, we have 4x below, and then the input is 0, we can have our answer here as 1. Okay, we can do that. So now, first thing is we need to factor out the 2 here, not 2x, sorry, the 2 here, this 2 only. So we can do that actually. So what happens is that we will have 1 all over 2 times sine of 2x all over 2x times tangent of 4x all over sine of 4x, all right, as x approaches 0. Now here we can apply a constant multiple law of limits. Basically, if you have a constant term here as a factor, we can just bring it out, like we can bring out 1/2 outside if it's a constant term, all right? So 1/2 is a constant term, so we can just bring it outside. So we have 1/2 times the limit of sine of 2x all over 2x times tangent of 4x all over sine of 4x. Now, here's the thing. Okay, here we can get the, wait, I forgot the, not the, yeah, the input. Okay, we can get the limit for the sine of 2x all over 2x because I told you, again, I'm going to say that once again, if you have sine and you have x here, and then the x here is just the same as x here, like we have 4x, then we have 4x as well on the denominator, and we have an input of 0, then we can get our answer as 1. But we're not done yet because you see, we have this one. We need to simplify tangent of 4x all over sine of 4x. Okay, we need to simplify this one. So how to simplify it? So let's have a recall in our lessons in trigonometry. Tangent theta is just the same as sine theta all over cosine theta. Okay? So that means if I have tangent of 4x, I can simply rewrite this as sine of 4x all over cosine of 4x. So with that being said, we will have 1/2 times the limit of, let me just copy the sine of 2x all over 2x. Then here, for your tangent of 4x, we will replace this as sine of 4x all over cosine of 4x all over sine of 4x. There you go. As x approaches 0. That's it. Okay. So now, this is a complicated fraction because first we have a numerator and we have a denominator. I mean, obviously that's a fraction, but what I'm trying to point out is that the numerator has a fraction, so fraction within a fraction. So we need to simplify that. So what we can do here is that, wait for a while. Wait, let me just copy the other terms so that we can easily go direct to the point. All right. So what we can do here is that we have sine of 4x all over cosine of 4x. So first, let's copy that. Okay, let's copy that. Sine of 4x all over cosine of 4x. Then times the reciprocal of the denominator. So basically, it's 1 all over sine of 4x. Right, 1 all over sine of 4x. If you're asking me how I got this, it's because that if in a fraction we have a all over b all over c all over d, all right? So basically, it's a fraction within a fraction. So what are we going to do in this case? So it's simple. Copy the numerator, which is a all over b, times in the denominator, you have to reciprocate it. Or in other words, switch the position of D and C. So instead of having C all over D, we will have D all over C. All right? So that's the same thing here for our for what we did here. Because here, right, we have sine all over cosine, then all over sine. So as a result, this would be sine all over cosine times this one. You see it doesn't have a denominator, right? Because it only has sine. But we can have a denominator for this one. So you see, it maybe look like as a whole fraction, but we can have it as a fraction. So you see, this is a whole function. There's no fraction, if you know what I mean. We can have 1 as our denominator here. Like x is just the same as x all over 1. 2 is just the same as 2 all over 1. So for any whole term, it could be a whole function or whatsoever, we can have a denominator of 1. So sine is just the same as sine all over 1. Now we reciprocate, we will have 1 all over sine. Oh, wait. But yeah, you get the point. So that's it. Now we're going to multiply together. Now we have sine of 4x here and sine of 4x here. So we can just simply cancel it out. So what's left is we will have the limit of, sine of 2x all over 2x times 1 all over cosine of 4x. All right, that's it. Oh, wait, I forgot to put the input as x approaches 0. So what are we going to do now? Now we can evaluate our limit, or yeah, we can find, yeah, you could say that. We can evaluate the limit. So we're going to evaluate each of the functions here. All right. So as a result, we will have the limit of sine of 2x all over 2x as x approaches 0 times the limit of 1 all over cosine of 4x as x approaches 0. Okay. Oh, what's this? But anyway, so let's get the limit of sine of 2x all over 2x as x approaches 0. Remember what I said to you earlier that in here, okay, if you have sine and x on the denominator, and the thing is, the constant of x here on the sign is just the same as the constant of x here on the denominator, and the input of x here is 0, the answer would be 1. So just like here, if we have sine of 4x all over 4x as x approaches 0, that would be 1. Hence, this would be 1, right? That would be 1. Next here, 1 all over cosine of 4x. What we can do here is we can just directly substitute since we already manipulate our function trigonometrically and algebraically. So we can just directly substitute it. So we have 1 all over cosine of 4 times 0, right? Oh, wait, but it looks like it's 40. Let me just fix that, right? There you go. Much better. Okay. So cosine of 4 times 0 is cosine 0, obviously. And cosine 0 is actually 1. Cosine 0 is 1. Now you multiply them together, the answer is 1 half. And that is how you get your, how I get the answer in this given limit of a trigonometric function.